students, now today we will start the new topic, that is definite integrations, and most important for JEE. You will get two questions. JEE you will get 2 questions minimum. So that is very important question, a very important chapter, definite integration. Sometimes 2 to 3 questions will ask. Okay, let's see here what is definite integration. Actually, the most genius persons like Newton and Leibniz, these both they have defined this definite integration as continuous sum of an infinite series. The Leibniz and Newton, 300 years back, they have derived this one definite integration as continuous sum of an infinite series. In the olden days, it is very difficult to find out the areas of the unshaped figures. That time they have used this technique and they have find the areas under the curve. So that all the things, this is what you call as first principle sum of the infinite series. You have infinite figure, that also area you can find out. So the figure, you have to find the area of the figure, that we will find out. About this area geometrical representation, about the area I will discuss tomorrow. Because if I discuss now, what happens, you will not get that much interest right now. So I will discuss that thing later, tomorrow. And reality, what we have to go and what we have to study, that we will discuss today. So today I will discuss indefinite roots, like indefinite integrations. Using indefinite integration, how to solve definite integration. That concept today I will discuss. Tomorrow I will discuss about what is this infinite series, what is this continuity, all these things tomorrow I will explain. Okay, let's see here. Now what is the definition of the indefinite integration? Is integration A to B. Let's see here, integration A to B f of x dx. Integration A to B f of x dx is equal to, suppose f is a function, the integration of f of x is capital F of x. Suppose you are thinking f is a function and the integration of small f of x is capital F of x, and this function is in the interval a to b, then we can write as fx a to b, we can write like this, and this a is called lower limit, this b is called upper limit. So after finding the integration of this part, we will substitute the limits. First we will substitute b in this, so fb minus, then we substitute a here, fa. This is what we call as definite integration. In indefinite integration we used to get plus c, but in this definite integration, there is no plus c. In indefinite integration you used to get it plus c is the answer. But in definite integration you will not get any plus c, because we are fixed these intervals. We will say find the integration of in these intervals. So what is this here? F of x is a function which is bounded and continuous in the interval a comma b. F of x is a function which is bounded and continuous in a comma b closed interval. Then integration of a to b f of x dx can be written as fx integration. This is fx, this value b to a, and b substitute here fb minus, if I substitute a here, fa is the solution. This is called as definite integral of f between the limits a and b, where d by dx of f of x means differentiation of capital F of x is small f of x, then the integration of small f of x will be capital F of x. That is the reason this is mentioned here, nothing else. So you will understand with a basic simple example. See here you have a question like 0 to 1 e power x dx. You have to find the integration of 0 to 1 e power x dx. How to find this one? This is simple. You can integrate this one. What is the integration of e power x? E power x. E power x integration is e power x. Then you substitute the limits. These are called limits. 0 to 1 is a limit. Okay. Where 0 is called lower limit and 1 is called upper limit. This is what here a to b f of x dx, where a is called lower limit and b is called upper limit. Now e power x integration is what e power x. Now 1 to 1 first, next you substitute 0 according to this rule. So what I get here, e power 1 minus e power 0. So the answer is what? E power 1 is e, and e power 0, anything power 0 is 1. This is e power 0 is 1. So final answer is e minus 1. So in indefinite integration we used to get plus c, but here in definite integration we never going to get any plus c. Now today what I am going to do is I will teach a questions which are very important, and we will solve only problems today. Tomorrow I will come to the theory part. What exactly is this definite integration? Why we are using this definite integration? These are tomorrow I will discuss, because if I take the first class is that lecture, you may get bored. Well, let us see here, integration of pi by 4 to pi by 3 sin x dx. You have to find integration of this. Simple thing, integration of this, how to find? Let's find directly integration of this one. What is the integration of sin x? Let us find. Okay, let us find here. I am finding here. What is integration of sin x? Minus cos x. So minus cos x. Integration of sin x is minus cos x. And you have to put the limits. You have to substitute the limits. What are the limits here? Pi by 3. Here is the pi by 4. Let's substitute the limits here. So what I did here? Minus I will take common. Okay. I'll just discuss this in cos. Now substitute the upper limit. Upper limit is pi by 3 minus cos, and substitute the lower limit, that is pi by 4. This is the way to write. Okay. So I get as minus of cos pi by 3. Pi by 3 is how much? 60 degrees. Right? 60 degrees. This is 180 by 3. That is 60 degrees. Cos 60 is 1 by 2. So this value is 1 by 2 minus. Now cos pi by 4, that is 45 degrees, correct? That is 1 by root 2. This value is 1 by root 2. So what I am going to get the answer is minus of 2 root 2 is the LCM. 2 root 2 is the LCM. 2 table this is root 2 times minus root 2 root 2 cancel. This is 2 times. This is your answer. So answer finally you are multiplying with minus number on the numerator, minus into minus plus 2 minus, this is minus 2 root 2 upon 2 minus 2 root 2 upon 2 root 2 is the answer of this integration. This is what we call as definite integration. That is the reason I told you. If you know indefinite integration, then you can solve definite integration easily. So that's what the basic concept of definite integration. But tomorrow I will explain you in depth what is exact meaning and how to geometrical interpretation, how the formulas comes, how the first principle will work. All this tomorrow. Today we are going to solve some questions. Substitution method, by parts, how to use substitution method, how to use by parts. That all we are going to discuss in today's class. Understood?